Bulunara. Welcome back to our next phase of solving mathematics problem. Today we will be moving on to our second part of solving complex numbers. Let's have a look at some questions on complex numbers. This time around we'll be moving down into solving and looking at more questions in complex numbers. Let's have a look at some examples. Okay, in our last class we were solving purely 2024 paper. Complex numbers is 13 marks. We'll look at question number one. Question number one is just an overview of what we have already discussed. Question number one, we've solved it in our first lesson. A, B, C, D, E, F. We'll start with F today. Okay. We have completed E. Today we will start with F. And yes, we'll start with F today. So let's have a look at the second phase of solving complex numbers. That is this question. So let's have a look at this question. That is F in 2024 paper. I'll just write down the question. So this is F, another complex of complex numbers. So this is 2 C is 30 degrees to the power of 6. The question is saying leave our answer in polar form. Okay, let's try and answer that. So our question is saying that we need to solve this, or we need to find what is the value of 2 C is 30 to the power of 6. And whatever answer we have, we need to leave our answer as polar form. Okay. So what's the approach here? Now the approach here is when a function, this is in polar form, when a complex number is given to you in polar form, and when this polar form is raised to the power, any power, then I will rewrite this equation in the form of this, in polar form. So polar, we have looked at it in our previous video, that for any polar form we have an equation written as R C is theta, but in our case this is to the power of n. Now when a situation that you come across like this obeys what we call DeMoivres theorem. DeMoivres theorem says that for any complex number raised to the power of n that is equal to, we'll raise this power to r according to DeMoivres theorem. According to DeMoivres theorem, we'll raise this power to r, that is r to the power of n, sees this n is multiplied to theta. So that would be theta times n. This is what we call DeMoivres theorem. According to the theorem, DeMoivres theorem, that's what we're going to do if we come across situations like this. Yeah? Now let's solve them. So since this equation or this complex number is raised to the power of 6, then we'll obey the DeMoivres theorem, because DeMoivres theorem says any complex number is raised to the power of n, we will raise n to r and multiply n with theta. So I'll rewrite this as 2 sees theta to the power of 6, and theta in our case is 2 sees 30 degrees to the power of 6. Now what is r? R in our case is 2, and theta in our case is 30 degrees. So let's try and solve them. So this is 6 to the power of 2. Many students do this mistake in the exam. They forget to write down the formula. Formula is like your map. So that's theta. Our theta in our case is 30 degrees times 6. So what is 2 to the power of 6? Now let's try and find that in our calculator. So 2 to the power, our power sign, 6 is what? 64. So our answer here is 64 sees 30 times 6. So let's press 30 times 6 will give us 180 degrees, and this is our answer. Why? Because according to the question we need to leave our answer in polar form, and this is in polar form. But in some questions, when they don't mention polar form, take this out. If they just give you this question, and they say, okay, simplify 2 sees 30 to the power of 6. If they don't mention about polar form, that means we need to leave our answer in rectangular form, depending on the questions they ask you. For this question, they had asked you to leave our answer in polar form, and this is our polar form. But let's say if polar form is not there, that means we need to convert this in rectangular form. And how can we convert it? Like I've mentioned you in our last video, how to convert polar into rectangular and how to convert rectangular into polar. Let's have a look at one. Let's convert this into rectangular. Might in any case they ask us to leave our answer in rectangular form. Okay, for this case I don't know where's the polar in this calculator. I'll use this one here instead. Okay, how can I press polar? Pole, I think all of you have noticed that this is pole. Okay, I'll just zoom the camera for now. Okay, pole is here. This is pole. This button here is pole, and on top is what we call rec, and this is pole. So if you want to convert any rectangular into polar, we said pole. That is in polar form. But if you want to convert a polar form into a rectangular form, then rectangular, it's yellow, we press shift and polar. It will give you rec. Rec represents rectangular form. Okay, so let's convert using that principle. So let's convert this value into rectangular. If in case they don't mention in polar form, it's very particular. You need to be very particular on the question. Now if the question is saying in polar form, then we need to leave our answer as that. That is our answer. But if it's not asked in polar form, then we need to convert this into rectangular. And how can we convert it? We press shift, pole will give you rec, and then whatever value you see first, 64, so 64, comma, and whatever value comes second is 180, and close the bracket, equals. That gives us minus 64. So our answer in this case is minus 64. So this is minus 64, that will represent our real value, because we're converting polar into rectangular. So rectangular has real and an imaginary. So this is our real value. So I want to find my imaginary. Same concept that I showed you in our last video. You press recall. Recall is above 7. This is recall. So recall tangent. Press recall tangent. That gives you 0. So this is plus 0i. Okay, I can simplify this as saying it's just 64. So this is my answer in rectangular form. This is my answer in rectangular form. This is my answer in polar. Okay, let's check if this is rectangular. Let's go back and check if this is our polar form of this, or this is the rectangular form of this. Let's check, convert this rectangular back to polar. Okay, so that means we press this is our rectangular, whatever comes first. So we say pole. Let's use my red pen. Okay, pole, press pole. Whatever value comes here, whatever value first comes minus 64, so this is minus 64, comma, and whatever value is here, if it's positive, if it's negative, you press it, or in our case it's 0, so we press 0, close the bracket, equals, this is our R, because in polar, R comes first, then theta. So whatever comes first is your R. So in our case is 64. C is, you want to find your angle. Angle is recall, same process, recall tangent, and our angle is 180 degrees. Does it come back here? Yes. So that means this is our rectangular form. We can use this concept in converting either polar to rectangular or in rectangular to polar. We'll use the same concept here.